Hello there. In the first video of CAT Quant series, we will look at what are numbers, what are the types of numbers, and how to find the factors of a number. So, let us begin. Let us say we have a basket, okay? Now there are some balls inside the basket. Now, can you count how many balls are there? Yes, there are 8 balls. But had it been possible without having the knowledge of numbers with us? No, because numbers provide us with the ability to quantify the things and give it a particular number. For example, there are 365 days in a particular year, which is not a leap year. So, it is also known as a number. So now we will be looking at several types of numbers in a sequential fashion so that we can also understand when the questions are asked to us based on it. So the first type of numbers are the natural numbers. So natural numbers, as it says, the numbers are natural. For example, there are 365 days in a year, there are 24 hours in a day, and the numbers that we used in our day-to-day life and which can be used for quantifying the things are known as the natural numbers. So the natural numbers range from 1 to up to infinity, right? So this is about the natural numbers. Then there are whole numbers as well, which means that natural numbers with a zero added to it as well. So whole numbers are denoted by W, and the entire set of whole numbers is all the natural numbers with a zero in it. Then the third type of numbers that we have is the integers. Now, integers are of positive sign as well as negative sign. So the range of the integers is -3, -2, -1, 0, 1, 2, 3. It extends to positive infinity to the right side, and it extends to negative infinity to the left side. So this is the range for the set of integers, which is denoted by a Z. Now there are a certain types of integers as well. So the types basically are, see, firstly, even and odd numbers. So you must have encountered these terms when you have learned maths earlier. So even numbers are of the form 2k, and odd numbers are of the form 2k plus 1, where k belongs to Z, the set of integers. So every even number ends with a 0, 2, 4, 6, 8, and every odd number ends with 1, 3, 5, 7, and 9. So this is about even and odd numbers. Now we will look at the second bifurcation of integers, which are prime and composite numbers. Now, before learning what are these prime and composite numbers, let us look at one thing, which is factors of a number. So a factor is basically a number that divides the given number perfectly and leaves no remainder. For example, if we are given the number 4, then factors are 1, 2, and 4 as well. Because 4 divided by 4 is equal to 1 and there is no remainder left, right? So, such numbers are called factors of a particular number. So, let us see another example. Let us say 12. So, 12 has the factors 1, 2, 3, 4, 6, and 12. Okay. Now, there are two types of numbers that can be defined based on the number of factors they have. So, the first type is prime numbers, wherein the number has only two factors, 1 and itself. For example, 2 has only two factors, 1 and 2. 3 has only two factors, 1 and 3. 17 has only two factors, 1 and 17, and so on. So the list extends up to infinity, like there are infinitely many prime numbers. So some of the prime numbers less than 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, then 41, 43, 47, then 53, 59, then 61, 63, 67, 67, then 69 is composite, and so on. So you can remember the prime numbers up to 50. Okay. And also there is a special aspect about the prime numbers, that if a prime number is greater than 3, then it will be of the form either 6k plus 1 or 6k minus 1, which means that every prime number of the form, like every prime number greater than 3, is of the form 6k plus 1 or 6k minus 1. You can verify it here as well. Like 11 is 12 minus 1, 13 is 12 plus 1, 17 is 18 minus 1, and 19 is 18 plus 1. And it goes so on and so forth. But the vice versa is not necessarily true. Okay. So this is all about the prime numbers. And the composite numbers are the numbers which have more than two factors. Okay. So composite numbers, for example, 4 we saw, then 6 also has a total of 4 factors, 1, 2, 3, and 6. Then 9 has 3 factors, 1, 3, and 9, and so on. So these are the composite numbers. Now there is another aspect of numbers, which means perfect numbers. So perfect numbers are the numbers wherein sum of all the factors including the number is twice the number. For example, let us say 12. So 12 has the factors 1, 2, 3, 4, 6, and 12, right? But if you do the summation over here, so 2 plus 3 plus 4, 9, 9 plus 6, 15, 15 plus 1, 16, and 16 plus 12, 28. So here the summation is greater than twice the number. So this is not a perfect number. Okay. So this is pretty much it about the perfect numbers. Now let us look at the next type of numbers, which are rational numbers. So rational numbers are basically of three types, or three types of numbers can be called rational numbers. All the integers that we had seen are rational numbers. Then all the terminating decimal numbers, which means that the numbers like 2.35, 12.50, 16.96667, and so on. So these are called terminating decimals, wherein the number of digits after the decimal is finite. And there are third type of numbers which are non-terminating recurring decimal numbers. So for example, 0.25252525 and so on. So this is a non-terminating decimal number. Okay. Now, any rational number basically is of the form P by Q, wherein P comma Q belongs to the set of integers and Q not equal to 0. Okay. So every rational number will be of this form. And every number of this form will also be a rational number, wherein the P and Q are integers and Q is non-zero. Okay. Now let us see how to represent such non-terminating recurring decimals into fractions. Okay. So here the digits 2 and 5 are getting repeated alternately. So we can say that 0.25 bar is the representation for such number. Okay. So here what we generally do is, see, we write this to be equal to the digits inside the bar, so which are 2, 5, like all the digits after the decimal. So if it was 1 and then 2, 5 bar, then we had written 1, 2, 5. Okay. So 25 divided by, see, now count the number of digits from left to right. Okay. With the bar present. So 5 is a digit, and since it has a bar above it, we will write a 9. 2 is a digit, it has a bar above it. We will also write a 9. Okay. So the value of this fraction is 25 by 99. But what if I tell you the number was 0.125 bar, wherein the bar is on 25. Now we can write it as 125 divided by, see, 5 has a bar going from left to right till we reach the decimal. So 9, then 2, here also a 9, and 1 does not have a bar above it. So we will add a 0 for it. And now, reducing it to the maximum possible form, we can write it as this is 25 and this is 198. So this is equal to 25 divided by 198. Okay. So this is how you can represent the non-terminating recurring decimal numbers into fractions. And if you are given the fractions, you can do the same job vice versa. So if you were given that the number is 25 by let us say 396. So what you would have done is you would have tried to reduce this in the form of 990. Okay. So multiply by 2.5 on both the sides. So this would have been equal to 990 upon 25. So 25 into 2.5 is equal to 25 to the 50 and 12.5, 62.5. Now we can write it down as 62.5 can be further written as 625 divided by 9900. So you could have said that the number is 0.0625 and bar on 25. So the number in the numerator is 625 and this is 9900. So this is a way of how to convert a number in the fractional form to non-recurring or recurring decimal form, whichever is possible. So now let us look at the different types of numbers, which is the irrational numbers. So irrational numbers are the numbers which are not rational. For example, root 3, root 5, and root 25. Now out of these, which one are the irrational numbers? C. Root 3 is equal to 1.7321. Root 5 is equal to 2.24 something. But root 25 is equal to 5. So this is a rational number and these are the irrational ones. So irrational numbers are of this form in the square roots. Now see, sum of two rational numbers gives a rational number. But if you add a rational with a irrational or add two irrational numbers, then it will always result in an irrational number. But it won't be possible in one case, wherein the first irrational number is like this, and the second irrational number is negative of the first one. So this will result in a zero, which is a rational number. Okay. So this is pretty much it about the irrational numbers. Now let us see the next type of numbers, which are real numbers. Now real numbers technically means the numbers that are real, that are possible to exist in the surroundings of us, right? So all rational and irrational numbers are real numbers. Okay. And the numbers which are not real are called imaginary numbers. Now, in the case of imaginary numbers, you can remember one thing, which is an iota. It is represented somewhere by I or by j, small j. Now, this is equal to square root of -1. Okay. So now you must know that in the square root, for this to be real, the square root has to be positive. Like the number inside it has to be positive. But when it becomes negative, it becomes an imaginary number. Okay. And Complex number is the combination of real and imaginary numbers, which means that a complex number can be real as well as imaginary. Okay. So this is pretty much it from the types of numbers for now. And now we will look at the second half of our video, which is factors of a number. So as already explained, what are factors of a number? So let us consider a number is of the form a raised to power b into b raised to power q into c raised to power r and so on. And a, b, and c are prime factors of n. Okay. For example, if we have a number n which is equal to 12, so 12 can be written as 2 to the power 2 into 3 to the power 1. Okay. 2 and 3 are the prime factors of 12, and the exponents are given, which are the natural numbers. Okay. Now, the first thing that we can decode from this is the number of factors of n. So number of factors of n is given by p plus 1 into q plus 1 into r plus 1 and so on. For example, in the case of this, we had the factors as 1, 2, 3, 4, 6, and 12, right? So these 6 are the factors, and also using the formula 2 plus 1 into 1 plus 1, which is 3 into 2, which is also 6. Now let us look at the next formula, the number of ways of expressing n as a product of two factors. Now there are two cases in it. Case 1 is that n is a perfect square, and case 2 is n is not a perfect square. Now if n is a perfect square, then this is equal to 1 by 2 into p plus 1 into q plus 1, r plus 1, and so on, plus 1 if n is a perfect square. And this also includes root n into root n is included in here. Okay. So if you had to exclude it, then you would turn plus into a minus. Now, if n is not a perfect square, then the formula is 1 by 2 of p plus 1 into q plus 1 into r plus 1 and so on. Okay, fairly simple. So 12 is not a perfect square in the example that we are considering. So the number of ways of representing is 1, 12, 2, 6, and 3, 4. And also, looking at the formulas, we can say that it is half of the number of factors of n. So yes, it is half of it, which is 3. Now, let us look at one more interesting thing, which is sum of all factors of n. Okay. So the sum of all the factors of n is given by a to the power p plus 1 minus 1 by a minus 1 into b to the power q plus 1 minus 1 upon b minus 1 into c to the power r plus 1 minus 1 upon c minus 1. Okay. Now, if we look at the example that we had, so here the sum of all the factors will be equal to 1 plus 2, 3, 3 plus 3, 6, 6 plus 6, 12, 12 plus 12, 24 plus 4, 28. Okay. And using the formula, we will get 2 to the power 3 minus 1 upon 2 minus 1, which is 7 by 1, which is 7. And this is multiplied by 3 to the power 2, 9, 9 minus 1 upon 3 minus 1, which is 8 by 2, which is 4. So 7 fours are 28. So yes, the formula has been verified as well. Now let us look at some other things related to the factors of a number. So the next set of things are product of all the factors of n. Okay, so this is an interesting one. So if the number of factors is equal to d, let us say, then the product of all the factors of n is equal to n to the power d by 2. For example, we had looked at the example earlier, which was 12. And the factors were 1, 2, 3, 4, 6, and 12. So the product of these is 6 fours are 24, 24 6 are 144, 144 into 12, which is 12 to the power 3. And yes, since the number of factors are 6, so 12 to the power 6 by 2, which is 3. So this formula is also verified. Now, the number of ways of writing n as a product of two co-primes. Now, this is an interesting one. So here we will count the number of distinct of the number n, which is small n. And the answer will be 2 to the power n minus 1. So see, 12 is 2 square into 3. Number of factors 6, and the number of prime factors are 2, 2 and 3. So 2 to the power 2 minus 1, which is 2. And the pairs will be 3 and 4 and 1 and 12. Okay, so these are two co-prime pairs and their multiplication is also 12. Now the next thing is number of co-primes to n that are less than n. Okay, so this function is a this value rather is represented by phi of n, which is equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c and so on. So for this example of 12, the number of co-primes to n that are less than n will be equal to 12 into 1 minus 1 by 2, which is 1 by 2, into 1 minus 1 by 3, which is 2 by 3. So this is equal to 4. And the 4 co-primes will be 5, 7, 11, and 1. Okay, so these will be the 4 co-primes to 12. And the last thing that we will be looking at is sum of co-primes. So the formula for it is also pretty simple. So sum of co-primes is n by 2 phi of n. So looking at this example, we can say that the sum of co-primes is 5 plus 7, 12, 12 plus 12, 24. So it is equal to 4 into 12 by 2, which is 24. Okay. So that is pretty much it from this particular video. And in the next video, we will be looking at the rules of divisibility for a number. So thanks very much and happy learning.